Alright, Crewton Ramone's House of Math, one quick lesson. So this is great for learning and patterning, right? Now we could keep going, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, and then count 4s. That's just twice as much, 4, 8, 12, 16, 20. 4, 8, 12, 16, 20, they should be able to 16, and the 12, they should be able to see it in there. But do you see the patterning right here? That's all it is. If I teach it this way, that's all I get, is a multiplication lesson. Right? Okay. But if I teach it like this, with some blocks, let's get some extra blocks in there. Oh heck, let's get a whole bunch more blocks in here. Actually, let's not put them all in there. Now, do you see, what do I have here? I have, there's my blocks. Over here, I'm going to put my picture. Hey, can you count by 4s for me? 4, 8, 12, 16, 20. All right, so this whole thing is 20. One side's 4, this side's 5. You see that? There's my 4, then 5 down. And I can see 4 is contained in 25 times. What am I counting? I'm counting 4s. There's all 5 of them. Let's get these guys out of here. And I can see, oh, look, now look at my lesson. Now how much more math have I learned that I see the inverse function, that I see the multiplication and the division, that I see that all I got to do is turn the blocks the other way, and now I've got 5, and of course that's going to be 4. How much more quote-unquote number sense do they get, since that seems to be the buzzword now, right? We're giving them number sense when you do this, instead of just doing a list of multiplication tables, right, where they're just fooling around with numbers. Because now they can see, oh yeah, we really are talking about, and can you see that this times that's going to be this and this, right? 5 is contained in 20 4 times. Because actually now what I've done is I've turned these into 5s. And I've got 4 5s there. So there's 4 that way and 5 that way. And there's 5 that way and 4 that way. But it's the same thing. It's the same blocks. Right? But do you see how much more math just using the blocks like that than just doing multiplication tables? Now we want to do both. Not just one or the other. I'm not saying one or the other is best way. And this is the other thing that's going to come up in the teacher training, is that I am, again, I've said it, I'm not guru, you are guru. They're your kids. So you do, you know, but it's not, there is no one way. This is what makes me crazy, is people want a curriculum that's just one way. Everybody does it the same way. No. And then that'll be the problem, is you'll get these disciples of Crewton Ramone. Well, Crewton Ramone said to do it this way, this way, this way, this way. No, I did not. I did not. All I said was, what you need to do is, here are some lessons, mix it up how you want. Right? And it's not going to be the same way every time for every kid. Right? It's going to be different lessons for every kid we got going on here. And you figure out which way to put first and which way to put second and so on. Alright, but so that's why with the blocks you get so much more. Right? It's just it's even just this.
Rayman, you're too loud.
He's singing. He's 6, he's having a fun time. It's almost bedtime, isn't it? Brushing teeth and stuff.
It is. It is.
Alright, so now what have I got? Well, what I've got here is I've got 7 across, 21, and the down is 3. And see, your son's still working on counting 7s, because 7s, there's no pattern, right? 7,
Right.
14, 21, 28, and keeps on going. That's not right. Most of them, 35, after 5, you got a pattern going on there. 2, 4, 6, 8, 10, 4, 8, 12, 16, 20, 5, 10, 15, 20, even 6s, 6, 12, 18, 24, 30. But 7s just keep going, right? So, you can use this for an add-ins lesson. 7, what's 7 want? It wants 3. So it takes the 3 and there's 4 left. Right, so I got a 10 and 3. What's the 4 want to be? It wants to be 4 wants to be what? It wants to be 10, so it takes 6 out. Oops, where's the camera? There it is. And I have 1 left, so now I'm 21. Now, 1's unhappy because he wants 9 and we're only going to give him 7. So we got 28. And then what does 8 want to be? 8 wants to be 10, so it takes 2 out and there's 5 left. Right? And see, there's your subtraction in there also, right? Taking 2 out of 7 to get 5. You see how it's a compound lesson? See how much more going on all at once? And then 35, what comes after that? Well, 5 wants the 5, and so it takes 5 and there's only going to be 2 left. Etc. And then when you're building with the blocks, like I said, you get more number sense because you get more stuff going on. They can see it. It's not just memorizing multiplication tables. They can see what's going on. We can draw pictures of it. We can play around and it's fun. And we get a whole bunch more math all at once. Because the idea, again, is right now we are here. And to see where we're heading is calculus. Where we're heading is being able to speak the language of mathematics. So what we want here is we want concurrent lessons. Right? Here's our basics. What are we trying to do at stage 1? At stage 1, we're trying to teach basic operations: addition, subtraction, multiplication, and division. So what do? We can do, of course we do add-ins and addition and subtraction and multiplication and division, but all of this multiplication and division is just teaching counting quickly, right? And then, right, percentages and fractions and all that stuff, it's still just the base building block because the way we teach it, it's all just teaching multiplication, addition, add-ins, etc., right?
Yep.
And then pretty soon you got this thing down, and, right? And then you got this and this and this and this and this, and now we're teaching fewer lessons for the next step, and pretty soon they should have all this stuff down, right? And pretty soon now we can focus on calculus. But kids can't be doing, like, say over here in algebra or wherever we're at, we're doing, like, say, quadratic equation. Well, they can't do fractions. And they don't have their multiplication down completely. And they can't do division. And they don't understand the concept of square root. And they don't, right? How the heck are they supposed to be able to do the quadratic equation when all of this is missing?
Yeah.
Right? And see, we can start putting the algebra in way earlier because the way we're going to teach it, that quadratic is just going to help, reinforce all the stuff we already know. But we don't have to know it first in order to do it. We're going to, right? See what I'm saying? We're going to use that to teach the other stuff. Mm-hmm. All right. That's...
Well, and they are pushing calculus out of the curriculum, right?
I'm sure.
Hell,
these guys can't even teach fractions. How are they going to teach calculus?
Well, they're pushing it further and further out.
Yeah, because what they're trying to do, what do they do? Like I said, what do we have? We're going to start going down the list, and when we get after what we call the basic math, the basic operations, after fractions, decimals, and percents, then it's what? Then it's going to be geometry, trigonometry, right? And then algebra, and they've got the algebra busted in the pre-algebra, core algebra, and advanced algebra. So now instead of being 1 year, it's 3 years, right? I mean, it's ridiculous. And then they're taking geometry and doing the same thing. Instead of just having a trig course, we've got geometry first and then some trig, right? So that's, instead of being 1 year, now it's 2. So now there's 5 years. You're running out of time in high school when it's only 4 years, right? And then they got calculus. They got pre-calculus and calculus. And then the calculus, they're busting it into 3 or 4 different things instead of making it, right? And what it needs to be is, in 4 years is more than enough time to teach all of that stuff. And 12 years, certainly 12 years is enough. In 12 years, are you kidding me, is enough to go from counting to calc.
Yeah.
If you do it right. In 12 years, from kindergarten to 12th grade? But no. Okay. Anyway, that's the lesson. That's the idea, is that we're going to, right, concept-based teaching. Today's concepts was numbers made out of numbers, want to be 10, and count the big ones first. Those were the basic concepts that we did today.
Okay.
Right? Oh, and then of course square roots and completing the square and stuff. And then see, completing the square, completely taken for granted. Easy. Right? I'm not going to give him rules.
Are you going to post this? Because I'm sure I'm not going to remember everything.
Yes, I will. I've got the camera rolling for a change. So yes, I'll have it on there. I'll either post it or it'll be in the parent training as a little, little segment.
Okay.
All right, excellent. Crewton Ramone's House of Math for more.